So far we have done sequential execution. That means that each statement in a program executes just once, and they are executed in the same order in which they are listed. In this lecture we will be using something known as selection statements, or we will be making a decision so that we have more flexible programs. That means that while making a decision, let's take an example of a roundabout. Let's say someone is driving on a roundabout and he or she arrives over here. Now he or she can go left, go straight, take a right, or maybe take a U-turn from here, and he or she can go in various directions depending on what the decision is. This is a quite complicated roundabout, but the picture is shown just so that you can understand that programs do have to make a decision based on some input or based on some condition being true, so that they can decide where to go next. For that we will be using something known as an if-else statement, or if statement, or an if-else statement. Before going into the details of the if statement and the if-else statement, I've discussed this if statement briefly in the previous lecture wherever the need arises, but here we'll be discussing this if statement in detail. Before going into that, let's take an example of a generator automatic transfer switch. Generator automatic transfer switch is used to because we have load shedding these days, so whenever the utility or the KE supply turns off, the generator automatically starts. Now how the generator actually knows when the light is off, or when the electricity supply from the utility is off, it actually uses something known as a automatic transfer switch. It looks something like this, or maybe in bigger sense, actually I think it's a two-phase switch, not so sure about it. Sorry, it's a single-phase switch hopefully, and this thing is probably a three-phase switch, so that it has the crossbar, so that only the load is either connected to the utility or the generator supply, but not both at the same time, because obviously that will cause huge problems. So this crossbar is used to ensure that either the load is connected either to the utility or to the generator supply. So how does it know that it needs to turn on the generator and the lights are off, or the electricity supply is off? Actually there are several ways to do it. One is known as a relay logic. By relay logic, we can develop AND gate, OR gates, or XOR, or the logical gates. We are going to discuss that in next two lectures probably, what those gates are. Essentially they are AND gate is logical multiplication and OR gate is logical addition. We can also introduce timers in there, so and we can have something known as logical decision with delays as well, so we can use these timers as well. How can we develop this kind of logic is either using relays, or we can use relays and timers, or we can use something known as computer programming. So let's say this is a flow chart of a automatic transfer switch, and the flow chart actually defines how the program works, and we can develop the hardware for this flow which implements this flow chart using either the relay logic or using simple computer programming. But here if you can see closely, that here this shape actually signifies the decision making point, that if this condition is true, do this or do that, or if this condition is true, yes go here, no goes here. And let's say we have another if statement over here, that whether some condition is true or false. If the condition is true, go here. If the condition is false, go there. And whenever you see these kind of shapes, that means that we are at a decision making point. Now if we develop this flowchart behavior using relay logic, that means that all the hardware settings and all the timer settings has to be done by hand. I mean, we need to develop all these things, and whenever a change is required in terms of timers or in terms of some kind of a relay logic, we need to actually make or break physical connections in these wires. But if you are doing computer programming and you want to develop this flowchart in your computer program, it's very simple to do so. And if you want to change a few things, let's say you want to change the timer settings, let's say you want to change a few conditions, let's say another generator is online, you want to incorporate that as well, you only need to change the code. And it will have the same behavior as this thing, as this hardware based relay logic over here. So in the previous days and still these days, you might find this relay logic with timers built into some systems, but computer programming is actually much simple and easy to do if you want to make changes. And it's also possible if you can make changes over the air. Let's say the microcontroller in which you have programmed this logic is actually deep inside some embedded system, and you want to change the programming. It is actually possible to change its programming remotely using some kind of a network connection, and sitting in your office, you can just change the whole programming parameters and the timers as well without actually going into this thing, which is you change the dials and you set the relay settings and so on and so forth. Quick review of what relays are, and you will be if you are using microcontrollers to control a few heavier loads, so microcontroller outputs are basically 5 volts or maybe less than that. Maybe it's 5 volts and you want to control a 220 volt or a 408 volt load, so obviously you cannot connect them directly. You need some kind of an electromechanical switch, so that, such as a relay. A relay comes in various shapes and sizes. If you can just relay and check out this Wikipedia entry, so it comes in this shape as well, and it has various voltages, but this is the basic structure: single pole single throw, single pole dual throw, double pole single throw, and double pole double throw. So that means that it's very simple. Let's say you have here a 5 volt signal coming in. This thing is going to energize the coil, and it will close the switch so that A and B connections are made. And if you de-energize this coil, let's say the supply coming in from here of 5 volts is now 0 volts, the coil will be de-energized, and there is some kind of a spring over here which opens this switch, and A or B will be disconnected. And if we have a single pole dual throw, so this is known as normally closed connection, this is known as normally open. That means that if you do not have any supply, C is connected to B, and if you have a supply of 5 volts, A will be connected to C. Now this thing, this energizing voltage is essentially the control voltage, and here let's say C is the load and A is the supply, and you can, with a 5 volt signal, I can have 220 volts connected to this point, and there is an isolation between A, B, C and this input voltage which is coming in from the microcontroller. So with a small voltage, I can control the switching action of the, with a small switching voltage, for 5 volts, so the control voltage, I can actually switch to 20 volts or 408 volts if need arises. So let's say I have a double pole single throw switches. That means that I can connect and disconnect 2 lines at the same time just by applying a 5 volt or maybe a 10 volt signal. Relays come in many ratings, so you need to check out their data sheets. Let's say if it is possible that you might be required to use a 12 volt DC relay, and there are like AC relays as well. These AC and DC relay actually refer to what kind of input or control voltage is used to energize the coil. Let's say I have a 12 volt DC relay, so if I have a 12 volt signal coming in from this point and ground to this point, if there is a 12 volt signal, then A1 is connected to B1 and A2 is connected to B2. If I disable this control signal from some microcontroller or some other logical circuit, then this connection become open. And we have a double pole double throw, so we have 1 2 poles and 1 and 2 poles, and double throw means that C1 is either connected to B1 or A1. By C1 is normally connected or normally close to B1 when there is no supply voltage. If there is a supply voltage of, let's say, 12 volts, then C1 is connected to A1, and similarly C2 is connected to A2. If I disable the supply voltage of 12 volts or maybe 5 volt, whatever the relay is, then C2 is, due to some spring loader, C2 is connected back to B2 and C1 is connected back to B1. So we have, A1, B1, they could have like 220 volts or something like that. We can have 220 volts load and 220 volts source, and it depends on, usually these are essentially higher voltages and higher currents loads, but they are switching those loads using a very small control voltage. Relays comes in electromechanical variety. There are also also come in solid state relays, which are essentially transistor based. It depends on what the application is, and usually if you are using some DC relays, always use some kind of a diode in parallel with this thing, so that if you turn off the supply from here, the diode is connected in this fashion, and from here we have a, I mean, diode is connected like this. Let me draw it for you. Okay, so we have a diode connected in reverse actually. So the 5-volt supply coming in here is going to energize the relay. Once you disconnect the 5-volt supply, it's a DC relay actually. So once you disconnect the 5-volt supply, the electromagnetic field will collapse and it will introduce a back EMF. And if you do not have this diode in here, that back EMF will have disastrous consequences for your control circuit. It might burn off your microcontroller board here. So what we do is we always attach a diode for DC relay, so that whenever the switch is off, essentially the 5-volt supply is off and the diode was energized, and the circuit was, and the coil was energized, once it de-energizes, it's going to develop a back EMF in the reverse polarity, and it will, the resulting current due to the extremely high voltage spike is going to circulate inside this winding, because the diode has essentially very in milliohms resistance, and winding has also a very small resistance, but it's going to circulate here and the energy will dissipate in the winding of this electromechanical relay, and this energy will hopefully not go back towards your microcontroller or control circuit. If you are using AC based relays, we use something known as RLC circuit based snubber circuits. You might be reading or about that topic in your microcontroller or maybe in your power electronics course. Coming back to if statement, the if statement is actually run in this fashion. If I write if and we have a condition, and condition either resolves to 0 or 1, or that means false or true. So if this condition is true, that means that we have a statement, and that statement is run, and that statement enters the semicolon, so that if the condition is true, this statement runs. If you want to run multiple statements, if this condition is true, what you need to do is, instead of writing one single statement, we can have multiple statements. But for that those multiple statements, we can have, I mean, this is just for statement, we can enclose them in a curly bracket, so that if this condition is true, that means we enclose those multiple statements in curly brackets, and those all of those statements would run if this condition is true. So if you want to run just one statement only, there are no need for these curly brackets, and the if statement, the if condition and this statement ends with the first semicolon. So let's try doing a program over here. Let's say we want to check whether some number is divisible by another. Let's say we want to check whether the remainder is 0. So we are going to take the input from, let's say, numerator and denominator, and we want to check C out, and we ask the user that enter two positive numbers, and we are expecting or we should say enter two positive integers, because we want to use the remainder operator, and we are expecting that the user actually inputs integers only. We are not checking for we take the input from the user, the first input goes to n and the next input goes to d, and then we check. And actually we are not going for the error handling right over here. We just expect the user to be nice and enter the positive integers only. He or she should not enter the negative numbers, or he or she should not enter some fractional numbers as well. If you want to handle that, you can use some kind of an error handling code here, so as to make sure that the user only enters the positive numbers, whole numbers, and not anything else. But since we are just starting to use this if statement, so we are not going for the error handling. But error handling actually involves using if statement, that if the user enters a number which is less than 0, or if the user has entered a number which is not integer, then you ask again that please enter positive numbers, or you exit the program. So let's say the user is nice and we expect he or she to enter the numbers which we asked for. So if we say if n remainder or n modulus d is true, that means that, let's say the user enters the number 10, and for d he or she enters 5. So 10 divided by 5 is 2 and the remainder is 0. So that means this condition will, this integral expression using, involving the integers, this integral expression will resolve to 0. That means the statement which I'm writing next is not going to run. So I'm going to write, write C out, and I'm going to write n, and I'm going to write spacebar is not divisible by, and just write d over here, whatever the user has entered. And this if statement, and this whole statement ends with this semicolon over here, and that's it. Let's run this thing. I've already saved the file, and I've already entered two numbers. So wait in a moment. Okay, enter two positive numbers. Let's say the first positive number is 10 and the next is 5. So it does not run this line because this condition is actually false, because 10 is divided by 5, remainder is 0. So this condition is not this condition is not true anymore, so this statement did not run. So let's run this program again, and we go to execute and run, and it says enter two positive integers. So I just press let's say 12, and the next number is 5, and it says 12 is not divisible by 5 because 12 divided by 5, the remainder is 2. So any value other than 0 is taken as true. So that means that this if statement, this if statement condition is not true, and this statement actually ran. So let's check. That means that in whenever we have some kind of an integral expression, so and it's used as a condition, the value 0 means false and all other values mean true. So that means that if we want to check some condition, go for this. You can have some logical expression as well, or we can improve this program, such as we can use something known as the if else statement. Let's say that this thing is if n is and the remainder of n divided by d is not 0, then we are saying that n is not divisible by d. We can also use something known as the if else statement. Else, if that means that if this condition is not true, then run whatever is written right next to it. And similarly, else can also have, we can write in a statement over here. This does not mean that actual valid word over here, just saying that. Or we can have, if you want to run multiple statements, you just enclose them into curly brackets. You can just write statement 1 and then statement 2 and so on and so forth. But if you just need to run just one statement, you do not need those curly brackets, and just write one statement, and that statement ends with a semicolon. So I'm just going to write C out, and I'm going to say that n, and if this condition is true, if this condition is false, then this condition is going to be true. So this else is going to run. So I'm going to say n is divisible by, and I'm going to write d, and I'm going to write an L over here. So let's run this thing. And since I've changed the code, I need to compile and run again. I cannot simply click run because that would have ran the previous exe file without the changes. Since I've changed the file, so I need to compile and run again. So let's run this program. And sorry, enter two numbers. So I'm just going to say 10 and next is 5, and it says 10 is divisible by 5. So yes, it is, because there is no remainder. That means that this condition 10 divided by 5, the remainder would have been 0. So this condition is false. Therefore this if statement, if after this if condition, or after this if this statement did not run, the else statement actually ran. So that means that 10 is divisible by 5. So let's run this program again, since I've compiled it and not going to change anything again. So this thing, let's write 12, and the next number is 5. So it's 53. Oh, sorry, I just wrote it. So it says 12 is not divisible by 53. You get the same result. Let's say if I, sorry, it's just 12, and next is 53. 12 is not divisible by 5. That means that this condition evaluates to true, because 12 divided by 5, the remainder is 2. So any other value which is other than 0 is taken as true. So that means that the condition here is taken as true, and therefore this statement actually ran. Coming back to this topic, something known as comparison operators. Whenever we want to check for numbers, obviously for integer numbers or integral expressions, or those mathematical expressions which evaluate to integers, we will be using something known as comparison operator. This is for less than, this is for greater than, this is for less than and equal to, this thing would be greater than equal to, and this thing, pay attention that this thing is means checking for equality. Checking for equality, this means is equal to. This is not an assignment operator, this is a checking for equality operator. That means we want to check whether some number is equal to some other number. We want to check, we are going to use the double equals to sign. If we are using just single equal to sign, that would have been an assignment operator. So keep in mind, that's a common mistake which I mean literally everyone does, in the beginning. So watch out for this thing. And this operator, this single exclamation mark means not, or if you just put a false to it, the not false means true. If you put a true to it, the not true means false. So this thing, this not operator right next to the equal to sign means not equal to. So if I'm going to check, let's say if I have some condition, if I write 5 greater than 7, so this condition evaluates to false because 5 is not greater than 7. So the answer of this condition would be 0. So whenever we have this comparison operators being used, the answer would always be, or the result would always be either 0 or 1. So if I write 5 less than 7, then now the answer for this condition would be 1, and that means that if I write this condition with an if keyword, then this condition would be true, and whatever statement coming next to after this if statement is going to run. So if I write 5 less than equal to 7, this thing is also true because 5 is less than 7. Or if I write 5 greater than or equal to 7, this thing is not true because either 5 is not equal to 7 and 5 is not greater than 7, obviously. So this thing will evaluate to false. And if I write 5 equal to 7, that means the answer for this condition would be false because 5 is not equal to 7. If I write 5 is not equal to 7, the answer or the result of this comparison operator would be true or 1. Reason is 5 is not equal to 7, that means this thing condition is actually true. So we are going to use these things in some program. Let's write a simple program just to figure out a minimum of 2 integers. So I'm going to ask from the user, I've already written the integer main void and using namespace standard include iostream, and I've already saved the file, so it's not going to prompt me for that. So I'm going to see out, I'm going to say to the user, look, enter 2 numbers, or I should say integers, because I'm going to use this integer for these expressions. I'm going to take the input from the user and use the input operator to assign it to m. The first number goes to m and the second number is assigned to n. And if I'm going, watch closely, if m is less than n, if m is less than n, the first number goes to m and the next number goes to n. So I'm going to say cout, some space, cout. I could actually do this. I just have a tab over here to make it more simple to understand. Cout m, and I'm going to say that is the minimum of 2 numbers, and that's it. So I'm going to write otherwise if this condition is not true, so I'm going to write else and have a tab, such to make it simple to understand, even though I could have written in the same line, no problem at all. So I can just write cout. I'm going to write n is the minimum of 2 numbers. Either m is greater or sorry, if either m is less, or obviously if that's not true, obviously the n is the lesser of the 2 numbers. So I'm just going to run this program. Let's see. Enter 2 numbers. So if I write 12 and I write 25, it says 12 is the minimum of the 2 numbers. So the first number is assigned to 12, the 12 is assigned to m and 25 is assigned to n. So 12 less than 25, this condition becomes true, so this statement ran and this statement did not run. If I just run this program again, if I say that 50 and the next number is 10, so it says that 50 less than 10, that condition is now false, or the result of this comparison operator would be false, so or 0. So this if statement is not true anymore, this statement will not run. Else will only run if the condition given in if is false. So this else statement will run, and then it says that n, which is the next number, 10 is the minimum of two numbers. Coming back to these, we could have used this less than equal to or greater than equal to if the condition is required. This thing requires a special attention, because the common error is instead of using the equality operator, we actually use the assignment operator. Assignment operator is a single equals to sign. Let's say we want to check whether the user has entered a number which is equal to 22. Let's say if I ask integer n, and I say cout, and I say enter a number, and a simple program, or I should say integer actually, and enter an integer. It's a simple program asking for the user the input, and if I take the input cn goes to n, and I say if n equals to 22, I say cout n, and this is a statement equals 22, and that's it. And I just say NL, and if it's not equal to 22, I'm going to say cout n, and I'm going to say is not equal to 22 over here. Just going to say the user that whatever you are entered is not equal to 22. So this thing should work. Just checking. It's a simple program just to demonstrate the effect. So enter a number, enter an integer. So it says if I just press for example 10, so it says 10 is not equal to 22. This condition is false, because 10, we are checking for the equality. 10 equals 22, that means 10 is not equal to 22. So the answer for this condition evaluation would be 0 or false. So therefore this else is going to run and says 10 is not equal to 22. Now if I just run this program again and run, and this says if I just press 22, so yeah, it says yes, 22 is equal to 22. 22 equals 22. We check for that, and the condition output of this condition is going to be true. So n is equal to 22. Therefore this statement actually ran, and this statement did not, because the if condition is true. Therefore this runs, and else did not run. Now if I'm going to make a small change, we are checking for equality. Instead of writing for checking for equality, or the intention was checking for equality, instead of writing this, we write this n equals to 22. What is going to happen? Let's see. If I just run this, because I've changed the code, so I need to compile and run again, and since there is no syntax error, so if I write enter an integer, so let's write 44. It says 22 equals to 22. What simply did happen over here? 44 is assigned to n. We checked for n equals to 22, but here something else is happening. We are not checking for n equals to 22. Here what we have used is something known as an assignment operator. And assignment operator, what it actually did was, even though initially we assigned the value of 44 from the user or from whoever is running the program, it actually 22 is now overwriting the value of n. The value of n is now 22, and the result of this assignment, since this assignment actually successfully happened, and it always happens, there is no error in that, so that the result of this assignment is now 1, and the value of n is now overwritten, and this statement will always run. This statement will always run. So this thing is actually a logical error. It's not a compile time error, because we haven't made any syntactical error. It's not a runtime error such as divided by 0 and not a number if we have approached those limits here. This expression n equals to 22 assigns the value of 22 to n, changing from the previous value of 44 which we have just entered. But this integral expression is evaluates to 22 after it executes, and it's obviously greater than 0, so that is true. So that the condition is interpreted as being true, because only 0 means false. So the statement before the else executes, and the line here should have been written as, if you are checking for equality, should have been written as an equal equals 22 checking for equality. Watch out, it's a very common error, yeah, because we are using the assignment operator quite often, and now we are using the equality operator. Logical errors are hard to detect. If you know what you're doing, then, or some other programming can actually check whether the error is a logical, because logical error is not going to be checked by the compiler. It's not a syntax error. It's not going to be checked by the operating system, because you're not dividing by 0, or you do not have a not a number, or you do not have infinity happening over here, or you do not have some if you have some kind of a runtime error, that is actually not catchable by the operating system. So for logical errors, essentially no help exists. You need to be careful in your programming so that not to make logical errors here, because if you are dealing with some electrical power system, so you have to be really careful that your logic is true. You need to recheck it multiple times and in multiple scenarios. You need to check with multiple inputs as well. You need to simulate it with multiple inputs so that the program performs as you expect it to perform. Let's write a program which says, just a practice for this if statement. We are going to check if the user has input 3 numbers. We want to check what is the minimum of those 3 numbers. You can just make the same logic for maximum as well. So let's have a number. Let's declare 3 numbers: integer n1, n2, n3, and I want to have another integer for minimum, or let's declare it later on to store the minimum value. And we are going to say cout enter 3 integers. And once again, we are not checking for error handling over here. We are expecting the user to be nice and enter the numbers as he or she is supposed to, and enter the integers only. Cn, and take the input from the user, and the first input is assigned to n1, the second input is assigned to n2, and the third input is assigned to n3. And we just declare a variable integer minimum. Whenever you are requiring a variable, just use it or declare it there, and we just assume that n1 is the minimum. You're not saying n1 is the minimum, we are just assuming it. And let's say if n2 is less than minimum, that means that now we want to run the statement that minimum should update that, because n2 is less than minimum, and minimum now it contained n1 over here. So if n2 is less than n1, so now we need to override minimum, and we say we need to update it to n2. We are not even checking for the equality here. We are just checking one is less than the other, or the minimum 3 numbers. And let's say let's have another condition. If n3 is less than minimum, n3 minimum now contains n2 if this condition actually ran. So now checking for n3 is less than minimum, so that means minimum actually contains n2. So here, if this condition is actually true, if this condition is false, so that means minimum still contains the n1 over here. So let's run this program and see what we get. If n3 is less than minimum, so we say that we just update it. Minimum is now equals to n3. So let's say, and we say that cout, and we say that the minimum of 3 numbers is, and we just say whatever that is, that is now stored in minimum, and that's it. So let's run this program. Before running this program, just go through it. And let's say the user entered a number 3 numbers, and we just assume the first number is a minimum. Minimum contains n1 here. This will run. Okay, now if n2 is less than minimum, a minimum contains n1, so now minimum would be updated to n2. If n2 is not less than minimum, so minimum would still contain n1. So in either of these two cases, minimum will either contain n1 or n2, depending on which one of them is actually a lesser number. Now we checked the lesser of the number with n3. So if n3 is less than minimum, so we need to update it with n3, and otherwise minimum would contain either n2 or n1. So let's compile and run this program. Compile and run. Did I miss something? Oh yes, I missed another. Okay, so let's compile and run this program. It says enter three numbers. Let's say if I entered 12 and I entered 15 and I entered 18, it says the minimum of three numbers is 12. Now how it happened was that 12 is assigned to n1, 15 is assigned to n2, and 18 is assigned to n3. So we just assume that minimum of the numbers is 12. So n2, we are checking for n2. N2 is 15. 15 less than 12? No, this condition did not run. And N3, minimum still contains n1 because this condition did not run. So N3 is 18. 18 less than minimum. Minimum contained 12. So 18 less than 12 did not run. So minimum, this statement did not run. Therefore, this statement remained valid and it was not overwritten. And the minimum of three numbers is 12. Now let's run this program again. And just write, for example, 15, 13 and 10, and it says the minimum three numbers is 10. Now how did it work? We just assume that the first number n1 assigned to 15 assigned to n1, we just assume that minimum is 15. Now we checked for 13 is less than 15. Yeah, this thing is true. We need to update the minimum. Minimum is now n2. So n2 was 13. Minimum now contains n2. Now we checked the third time. The second time we checked for n3. 10 is less than n2, which is minimum here, and this condition also became true. So now minimum contains n3, which was 10, and we just the last updated value of minimum, the minimum of three numbers is minimum, is 10, and that's how the program ran. Coming back to the second last topic, the statement blocks have explained that if you want to run multiple statements, whether the if condition is true, you can use enclose them in the curly brackets. If you want to just run this one statement, you can just write one statement and end it with semicolon. And this curly brackets can be, containing multiple statements can be placed anywhere a single statement can be placed. So let's make an example of let's write an example of having a program which just outputs two numbers in ascending order. So going to this program, or before going to the program, let me revisit that program. If you want to check for the maximum of three numbers, so what we're going to do, we are going to just write integer maximum, right? And we're going to check whether n2 is greater than maximum, right? And whether we check, we just update it, and then we update whether n3 is greater than maximum, and we just update it. And we are going to say the maximum of three numbers is, and maximum, we are, instead of checking for lesser of those two numbers, we are going to check for the, we are just going to assume the first number is the maximum. We check, oh, if n2 is actually greater than maximum, we need to update it, and maximum. If n3 is greater than maximum, we need to update again for the maximum. If this condition is not true, the maximum would contain this thing, if this condition had been true in the first place. Otherwise, if both of these conditions were not true, then this condition will hold. So I can just run this, just for checking for maximum three numbers. So we can just compile and run, because we have changed the code. We need to recompile the whole code. Enter three numbers. So if I write 12, 15 and 11, so it says the maximum of three numbers is 15. So the first number is 12. We just assume that this is the maximum, and 2 is greater than maximum. 15 is greater than 12, that is true. So and maximum now contains 15. We check n3, which is 11. n3 is greater than maximum, it is not. n3 contains 11, maximum is contained maximum contains 15. So 11 greater than 15 is false. This statement did not run. So the last updated value of maximum was 15. Now going quickly to the topic of the statement blocks, I'm going to write a program really quickly, and it's it just outputs the numbers entered, the two numbers entered in ascending order. Just to save time, I've typed it in the code here, and let me explain that code. That here what we want to do is, if this condition is true, we want to run these three statements. This is statement, this is statement, this is statement. There's no single statement. So whenever you want to have multiple statements, you want to run multiple statements, just enclose them into these curly brackets. These curly brackets is actually known as the statement block containing the multiple statements. Those curly brackets can actually contain a single statement as well, if you want to. So if you have a single statement, no need for curly brackets, but if you use curly brackets with a single statement contained in those curly brackets, that is fine as well, no problem at all. But here it contains three statements, and these three statements, what they do is, they take the input from the user, integer xy, enter two numbers, whatever the numbers are, and we want them to be arranged in a ascending order. We want to say that this number is less than that, or equal to this thing. So this can, if the user actually enters a number, let's say 60. I mean, we're going to run this program, execute and compile and run. It says enter two numbers. I'm going to say 55 and 22. So it says 22 is less than equal to 55. I mean, that's what we wanted to happen, that in ascending order 22 is less than 55 over here. So what actually happened was this line actually ran, and this line says that now x actually contains 22 and less than 55. What we wanted to do was we need to swap the values of x and y. So to swap the values of x and y, we declared a variable, a local variable of type integer. We just call it temporary variable. I mean, just to name any name, and we assigned the value of x to here. So x here contains 55 because the first input was assigned to x and the second input was assigned to y. X actually contains 55 over here, and 55 is greater than 22. This condition became true, therefore this whole block is going to run. So we assigned the value of 55 to temp. Now temp contains 55. We need to keep in mind. Now we overwrite the value of x with y. Y contains 22. So now value of y, which is 22, is now assigned to x. Now x has the value of 22 over here. Y, and then we assign the value of temp, which contained 55, to y. So x, before running this whole block, x actually contained 55 and y contained 22. Now we need to swap the values of x and y. We need to have some kind of a temporary location to store the value of x. We assign the value of x to temporary location. Now temporary contains 55. We assign the value of y to x. Now x contains 22, and we assign the value of temp, which is 55, which was 55, to y, and now the values of x and y are swapped. So x contains 22 and y contains 55, and we see out this statement that x equals to 22 less than equals to 55. That's what we actually got. That's what we wanted to happen. So let's run this code again. And since I have not made any change, so I'm going to run this code. And let's say if I run this code and say 10, and the next number is 20, and it says 10 is less than 20, that means 10 is greater than 20. This condition becomes false, so the whole block did not run, and only the cout, I mean the values of x and y were not changed, or they were not swapped. The value of x was 10 and the y was 20, and it says 10 is less than equal to 20. So here the three statements, within the blocks, I mean they actually just arrange the values of x and y into increasing order by swapping them if they are out of order. So that interchange requires three steps with the temporary storage location known as temp. The program which we actually written should execute either all of these steps or should not execute any one of them. So we just enclose them into a statement block. Okay, so this temp variable that is declared is inside the block. So that means this temp variable is actually local to the block. It only exists within this block. It does not exist outside here. So that means that if the condition, I mean x is greater than y, is false, the temp will never have been created. It will never exist. So that means that you only localize the variables in which they are required. You just declare them and where they are required in the statement blocks, because after exiting those statement block, that would have not existed anymore. I mean, if you look closely, the main function, the whole body of this main function is actually enclosed in this statement block with these curly brackets. So we can have multiple blocks like here. We can have even more blocks here. So if I just declare some more blocks here, I mean I could have done that. You could have a nested if statement here as well if you want to. So that temp statement would be so that temp variable would have existed over here, I mean here from this point onwards to all the in containing blocks here, but not outside this original block. In lecture 16, we actually discussed something known as scope of a variable, in which the part of the program where the variable can be used or where the variable is actually visible. It extends from the point where the variable is declared to the end of the block which that declaration actually controls. So a block of that state, or the statement block, can be used to limit the scope of a variable, thereby allowing same name to be used, which we demonstrated in the previous lecture, for different variables in different parts of the program. So in this code, we have used a variable name n for three different variables. We have declared an integer n equals to 44, and this thing belongs to this block, which I can collapse it or extend it. N equals to 44, and if we print it out, the value of n would be 44 over here. Now I have made another statement block, and this I have declared another variable n. This n is going to hide this n. So in this block, this n is going to work, and the scope of this n extends to over 4 lines from here onwards to 1, 2, 3, 4. I mean, this first line, second line, third line, and fourth line. And after exiting this block, this n simply doesn't exist anymore. So that integer n, cout enter integer, we take the value for n whatever the user has typed written, and this n would be the value of the user which the value which the user has entered over here. Then we cout another block, and we cout n. I mean, no need for this actually, these curly brackets. If I just cout n equals to this thing, this n actually means this n, because this n is simply did not simply cease to exist beyond this point. Okay, so another block of code integer n, and this scope actually extends to these two lines, one line and second line, whatever the user, I mean, it's not even initialized, so it might just display some garbage value over here. And I mean, this n is going to hide the n which was available outside this block. I mean, here within this block, this n is going to work. If I just make another sub block over here, I mean that this n is going to be also available here, unless some other variable of same name is declared over here. Okay, so coming coming out of this thing, this n now ceases to exist, and n equals to the original n which was available over here. So let's run this thing. Let's run this code, and it says enter the in front of your screen, enter integer, and n equals to 44, which we actually inserted over here. So n equals to 44. If I say for example 66, so it says, let's see, enter integer 66. So it says 66, n equals to 66. Now coming out of this block, n equals to the original 44. Then we, if I can, okay, so just browse it down over here. So out of this block, n equals to, coming back to our program, yeah, coming back to n equals to 44, I mean the original n. Now we just declared a variable, and we did not initialize it, so it contains some garbage value of 62. And then after the ending of this block, I mean this n ceases to exist again, and we say cout n equals to the original n which equals 44. So if I run this program again, you might see some new value, garbage value. I mean, not necessary, but you will see that. So let's say if I write 88, and it says okay, some same garbage value over here, depending on how the program, I mean, we did not even initialize the value over here, so it contains any garbage value depending on what computer you are using. So just to quickly summarize, this program has three internal blocks. The first block declares a new n, I mean this thing, I mean this, the first block contains a new n which only exists only within that block, and overrides the, this block, I mean this is the original n. We have three internal blocks. There's one block, there's another block, and there's another block over here. So three internal blocks. I mean this n, whenever, I mean, exists only within this block and overrides or hides the previous variable n. So the original n retains the value 44 when this n is given the value of let's say 66 over here. So original n belongs here 44, and this n only exists over here. So whatever cout I'm going over here, and with this n, that thing is going to print the value of this. If I use the scope resolution operator, obviously I can go outside this block, which I've explained in lecture 16. The second block does not redeclare n, so the scope of this original n includes this block as well. So this did not redeclare or make another variable of type n, so obviously this n is actually here as well. Even, I mean this n is actually visible over here, unless this thing actually declares a new n over here, which it did not. The third block is like the first block, declares a value n and overrides the original n, but this third block simply did not initialize the local local variable n, so that output is the garbage value. So that means that a scope of each redeclared n extends only to the block in which it is declared, or any subblock which it might contain. So the last line, the last cout in the program, the last line is in the scope of the original n, so it prints the value 44. So to quickly summarize what we did in this, let me write the topic. Not the topic, is we write the summary of this lecture. So a summary of this lecture is we did we discussed the sequential execution. I mean the one line runs after the other line. If you want to make a decision such as a roundabout or maybe any programming decision, you will be using something known as an if-else statement. We also discussed the benefits of computer programming versus the hardware programming, such as the relay logic. And we also saw that computer programming is actually much more simple and much more easier to make changes. Otherwise, in relay on hardware based logic with timers, you need to physically change the values or the timer values. We also saw the if statement and the else statement, if else statement. We also saw the comparison operators. I mean, their evaluation leads to either 0 or 1. And keep in mind that the equality operator should not be confused with the assignment operator. Assignment operator yields to true, so that's a common error here. We also saw the statement blocks and how those statement blocks can be used to limit the scope of any variable which is local to that statement block. And statement blocks we will be using extensively if we want to run multiple statements if some one condition is actually being true. And we can also use statement blocks with else as well. So let's say if I have a statement and we have some condition over here. I mean, just writing, I have multiple statements to run, and let's say if condition is not true, so I can have multiple statements to run with else as well. So I can just do that else run these many statements if this condition is not true over here.